Hello. I hope everyone is having a good day today. Today we're going to have a look at even more trigonometric identities. In particular, we're going to look at 4 of them, and they are called the angle, sum, and difference formulas. Now, these 4 equations are given on your formula sheet. So there's no need to memorize them, but you need to know when and how to apply these formulas. So the 4 equations or identities of interest are these ones on our page. Sine of a plus b, cos of a plus b, sine of a minus b, and cos of a minus b. If you care about why these formulas work or how they come about, feel free to read the textbook pages 447 and 448. Again, the proof of it right now is not important. It's more important of how you know how to apply them and where to apply them. So let's jump straight to example 31 over the page. Oh, sorry, not 31, 28. It says here, evaluate sine of 22 degrees, cos 38 degrees, plus cos of 22 degrees, sine of 38 degrees. So it's really important for you to identify patterns because we've got multiple trigonometric identities to be able to apply. So in this case, we'd see that we are sining and cosining the same angle, and we're also cosining and sining the same angle. And so this is why if we look at the formula sheet, you'll go across and then we're looking at sining and cosining same angle, and we're adding as well the 2 terms. So we're really going to choose the first one here, that sine of a plus b is sine a cos b plus cos a sine b. So we'll write this down, the formula that we've selected to use. So we'll say using, and you'll copy this from your formula sheet, sine of a plus b is sine a cos b plus cos a sine b. Well, in our case, a is 22 degrees and b is 38 degrees. So where a is 22 degrees and b is 38 degrees. So directly applying this, we have that, therefore, sine of 22 degrees cos 38 degrees plus cos 22 degrees sine of 38 degrees. So if we look at the equation, sine a cos b plus cos a sine b gives us sine of the sum of the angle. So that equals sine of a, which is 22 degrees, plus b, 38 degrees. In other words, 22 plus 38, that's 60 degrees. And sine of 60 degrees is root 3 on 2. We can do something similar for example 29. It says to expand 2 cos of theta plus pi on 3. So what we notice is that we've got a cosine and we've got a sum of angles. So if you go to your formula sheet, we're looking for a cosine, so is this one or this one, but we're also looking for the sum of the angles. So we're going to pick out this formula to use. So first step, write down the formula you're going to use, just directly copy from the formula sheet. So using cos of a plus b is cos a cos b minus sine a sine b. For us, our a would be theta and our b would be pi on 3. So where a is theta and b is pi on 3. So therefore, 2 lots of cos theta plus pi on 3 gives us 2 lots of, well, we're going to replace a with theta and b with pi on 3. So it's 2 lots of cos a, which is cos theta, times cos of b, which is pi on 3. Take away sine of a, which is sine of theta, and then sine of b, which is sine of pi on 3. So we can then simplify. So cos theta is cos theta, cos of pi on 3 is 1/2. So we have 1/2 cos theta minus sine of pi on 3 is root 3 on 2. So we have root 3 on 2 sine theta. Let's multiply the 2 inside. So we get cos theta minus root 3 sine theta, and we're done. One more time to practice applying these formulas, we have example 30. So use one of the compound angle formulas to simplify cos of 3 pi on 2 minus theta. So we've got this time cos of a difference. So you go to your formula sheet, identify the one which has a cosine, and then particularly we want the one with subtraction. So then you copy down the formula which you want to use from the formula sheet. So we've got using cos of A minus B is cos A cos B plus sine A sine B. For us, our A is 3 pi on 2 and our B would be theta. So where A is 3 pi on 2 and B is theta. So in other words, therefore, cos of 3 pi on 2 minus theta. So let's apply our formula. Cos A, so that's cos of 3 pi on 2 times cos of B, so cos of theta, plus sine A, so that's sine of 3 pi on 2 times sine of B, in other words, sine of theta. Cos of 3 pi on 2, if you think about your unit circle, 3 pi on 2 is the coordinate 0, -1. So cosine is the x value, which means cos of 3 pi on 2 is 0. So that's 0 times cos theta plus sine value is -1 because that's the y value, -1 lots of sine theta. So that just gives us negative sine theta.